¿Cómo están?
Hello, can you hear me? So I have to walk behind the yellow line, I was told, and this I play and this has back. So I'm doing okay. Good afternoon to all. Thank you very much, Nicolas, for inviting me once again. And it's a great pleasure for me to be here. I am going to speak about what I've been doing for some time. Nicolas told me, don't come as a minister, talk about whatever you want. So I'm going to talk about what I want, but that's difficult because you have to think of something. And I decided to describe what I've been doing for some time, which is the processing of natural language. I will explain what it's about, but I will also explain what I learned about the relationship between science and technology in a world that has been very successful. And I'm going to speak more about science than technology because you see the technology every day. Okay, the history of computing starts with this gentleman who changed two in two occasions the history of computing. He was a scientist, a mathematician from Britain who wrote a paper by applying a problem to the logic that Gilbert had produced. But the thing is that in this case he invented the computing model and he defined the notion of what it means to compute something. And from then on we had the computers, etc. All computers are limited versions of these kind of machines he thought of. And this happened in 1936, and Turing changed the course of history. But then, 1950, in another article, he changes once again the course of computing and the course of history because he defines the concept of artificial intelligence. Turing starts a paper that says, I propose the following question: can machines think? If that question is asked to me, I say, well, no way. But in this occasion, he was changing the course of history because he was defining the notion of artificial intelligence, and he was presenting many challenges, and in this case with an example, which is the Turing test. This is a way of defining artificial intelligence, and he says, is on one side I have a wall and I communicate with a computer through a computer terminal, and on the other side a computer manages to fool me and make me believe that it's a person, then it will have passed the test of artificial intelligence because it's like a human being in this sense. And this produced a big debate throughout time, and this is a fabulous article because at the time he already presented all of the doubts that came up later and replies to the questions. But the interesting thing is that he showed that in the definition of artificial intelligence, the natural language, the one human beings speak, could be seen as a synonym of artificial intelligence. They say that human language is complete artificial intelligence, and by understanding human language, we can understand artificial intelligence. That is why the processing of human language is considered a branch of artificial intelligence in the sense of Turing, in its largest sense, replacing a human being. The processing of natural language is the combination of these two notions that Turing presents: artificial intelligence on the one hand, and then also the processing from a computational point of view. As my friend Javier Corto says, it's an engineering version of linguistics that studies the language of human beings involving sociology, psychology, etc. But this is the approach of natural language from an engineering point of view. So I would like to show you a video now, which I always show in my presentations, and people criticize me because I always use it. How many of you have seen a Space Odyssey? At the university, it's much less, so this tells something about your age. Every year, I see less and less people that have seen this film. So this is a film in which a computer rebels. It's so intelligent that it rebels, and the astronaut asks the computer to open the door, and the computer refuses. So the interface is a screen and the red dot, which is well known. And as you see, this is similar to Turing test. He is acting with a screen, a computer screen, and I'll show you the dialogue. Do you read me? Do you read me, Hal? Affirmative, I read you. I'm sorry, Dave, I'm afraid I can't do that. What is the problem? I think you know what the problem is just as well as I do. What are you talking about, Hal? This mission is too important for me to allow you to jeopardize it. I don't know what you're talking about, Hal. I know that you and Frank were planning to disconnect me, and I'm afraid that's something I cannot allow to happen. Why is Hal the ideal example of natural language processing? Because it does a lot of things that human beings do. Not only it listens and decodes what is said, but also it produces replies. When it says, "I'm sorry, Dave, I'm afraid I can't do that," it's ironical. It's using an it's using irony to say, "I'm sorry, but I'm not going to open the door for you." And it's irony that, and computers are very far from irony. The full analysis of natural language is extremely difficult, but there have been progresses. Why is it difficult? Because there is a concept that differentiates natural language from formal languages, which is ambiguity. Natural language is ambiguous all the time, not by definition, but all the time. This, for example, this sentence can be read in two different ways. "Call me to serve" is one of these interpretations, but depending on where you put the accent, it changes. And in this case, it says John killed an animal with a gun, and it could be John or it could be the animal that had the gun. So we know that animals don't carry guns, and that's why we can interpret this sentence. But from a syntaxis point of view, both sentences are likely to happen. Some of them are more difficult to interpret. This says, "My neighbor's dog barked to me." And it can be interpreted in different ways, depending on the world you know. And it can say also something about the person who speaks. It can tell a lot about the person who says this. And this ambiguity is extremely difficult because it requires that we know the world. So these are the challenges of natural language processing. The history of natural language processing is very rich and not that old. We are really far of understanding the load of these ambiguous sentences and how they can be interpreted, but we are close. We are getting close. And this is a bit of story of processing of natural language. This is a process that was called Georgetown process. Georgetown University in 1954 had a project to translate from Russian into English, and you imagine why they would want that in 1954. And IBM publishes this in the press at the time. It says Russian was translated into English by an electronic brain for the first time. And then there is a description saying why no practical result had been achieved until IBM 701 appeared, and a girl who knew nothing about Russian wrote it down, and then she got a translator. IBM says that it's not possible to put in a book in Russian and get one in English, but a doctor from Georgetown University said that in 3 years or so, this problem will be solved. So translation is the first problem of natural language, and it's the most difficult one. But what they did was to put in 6 sentences in Russian, and then they got 6 sentences in English. And then natural languages start being processed on the basis of 2 models. One that uses rules and models that are known by IT experts because they are the ones that are behind formal languages and build syntaxes. And this is what Chomsky worked on, and he was a leader. And then another model by Claude Shannon, who is the one who created the theory of communication, who analyzes mostly speeches, spoken language, and the 2 models started diverging, one more statistic, the other one more based on rules. And this happens between 1960 and 1970, and many projects come up, and people would say that in 2 years the question of natural language would be solved. In the 70s, a very interesting thing happens. Firstly, the ALPAC report. It's a commission in the US who spoke about the Georgetown project that had been submitted 10 years ago. And they said, this is a disaster, it doesn't work. If you translate from English into Russian, etc., it's very complicated. It doesn't work well. It's better to pay to pay a translator. We are going to put the money elsewhere. And then there is a 15-year gap in processing natural language. In the meantime, some people were working on this translation, but they didn't have much financing or resources. And then Chomsky said that natural language could not be represented with finite state tools. And he also said that the notion of probability in a sentence under any interpretation didn't make any sense. And Chomsky's influence was so big that he helped during this period of winter. The statistics method were separated, and some people were working on them, but not many. This is what is called the winter of artificial intelligence between 1970 and 1985. In the 80s, once again, empirical methods, the noise channel, etc., came back. The statistical model and others. And here's a very famous sentence. Every time I fire a linguist, the performance of our speech recognition system goes up. The thing is, we don't need to analyze what is going on in languages. It's enough to count and to tell words. I always mock my linguist friends with this sentence, but this guy worked in IBM and he proved that statistical methods for languages established the basis for the big development that came later, that came in this century. I have lived all this change. When I started studying, the rules method was the valid thing, and the statistical methods started much later, at least for our group, at the beginning of this century. During the first decade of this century, 2000-2010, there is a new movement, machine learning, automated learning. I've talked about this before. These programs teach on the basis of data. The methods had already been invented, but here three things are done. Firstly, there are data people who started compiling data and taking notes, saying this is a sentence, this is a football document, or saying this is the syntaxis tree of this sentence, etc. And they remain as data. Second thing, computation capability, things that become possible thanks to the computer. And thirdly, those who did the processing of natural language and the machine learners become friends. So the combination of methods inside the processing of natural language causes a revolution. All fields suffer this revolution. It happened in physics, it happened in astronomy, and now it's happening in economy. From 2019 onwards, we have deep learning, which is a special version of automated learning with neuronal networks, which uses much better all the computing capacity available and the enormous amount of data also available. And it's been a revolution because it has covered everything that relates to the processing of natural language. Now everything is done with deep learning, and there is a forecast that we will be able to solve the question of artificial intelligence soon thanks to the deep learning methods. And those of us who are working on something else start to think about another winter. We think that we are making a lot of progress, but that in order to detect the ambiguity of how, there's a long way to go. Is that bad? Well, I don't know. They asked me about singularity, and I don't really believe in it. But if they ask me about Go player, well, I didn't believe in it either. So some things are being done very well by using neural networks. And these three guys, you see the names here, won the Turing Prize. And Benja will be here in Uruguay for the AI event at the end of the year. So they won the prize. And they had been learning since the 80s in neuronal networks and their theory. They had to wait to be caught up by computers, to be caught up by computers and the technology. And then my forecast is that linguists will come back. People say, well, putting a neural network in a task that was done well will make this task better. And we are starting now, we are going to start investigating more difficult things. How am I doing with my time? I have no idea. Can you please click on this link? I just want to give you this example on technology. I'm not going to talk about technology a lot because you see technology all the time. Siri, Alexa, Google translators, all these things are out there and they work. They didn't work a while ago, but now they do because of the consolidation of many methods. But you can see how interesting this is. Do you want to write something here? You can write down GX29 is now, and then we'll complete the text. Now it's not working. I didn't do this. It's online in the internet. Or it's killing the effect I wanted to have. I don't know. I have no idea why it's not working. You can turn it off and on again. Can you turn it off? Okay, put in another sentence. And then you have to complete this. And this is a clear demonstration that technology not always follows. But I don't know, I have no idea what's going on. So now it's working. GX 29 is now employing beta. This is the final system for Sony, etc. So they are guessing what you're going to do. Well, this has been done in a quite simple way. It uses a language model that tries to predict the following word based on the previous ones. And it's totally based on the notion of probabilities of a sentence, which according to Chomsky was useless. It can be done because there's a huge volume of data that produce information based on what there is out there and learn about the relationship between words. And you start discovering patterns and you don't even know how this happens. But it includes paragraphs, and this can be predicted too. It is trying to create a text, and it's doing it. It's like magic. But actually, it's quite simple technology from a technological point of view, but it contains many data and neural networks. So this is the technology of things that can be done. How am I doing with my time again? Now, look, what I learned about the processing of natural language, in case you are interested. Undoubtedly, it started growing, and it is making progress at a phenomenal rhythm. There are countless publications, and it's amazing how these changes are taken up by the industry. In the previous presentation, they were talking about chatbots and how they are included in GeneXus now and how you don't need to be a specialist, etc. And what have I learned? What has my experience been? The first one is that by the examples I gave you, you've seen that those who are very famous are not always right. And Chomsky is a case in point. He's an oracle. He's not an oracle. He was a genius, but he was an oracle. And that is why it is necessary to approach these kind of things with a critical spirit. When I'm going to eat something, I am also critical with regard to the food I'm eating. Secondly, scientific discussions are richer than technological discussions, but they should not stop us. In the paper I recommend you to write by Peter Norby, Chomsky, it would seem that I have something against Chomsky. Chomsky says, well, with neural networks and statistical methods, we are doing number crunching, but we're not learning anything. We don't know what's happening inside it. And Norby says, well, this is what we do with most things. We don't know how, but they work. And this discussion is very interesting. the discussion between what we learn versus what works, and there has to be a balance, which is the balance between science and technology. In fact, we have to keep scientific discussions that make us progress, but we have to understand that technology can follow its own rhythm and does not preclude the progress of science. Natural language has many processes that can be modeled. Thirdly, the academy and the industry play better together, but they shouldn't be mixed up. Another very interesting phenomenon of natural language is that the main players in the field of natural language work, guess where? Work for Google, for Facebook, for Microsoft. The big internet companies have recruited all these people. And this is not necessarily good. They should be at the university, and Fernando Pereira, who is a very big player, works for Google, but he also works at the university. And it's interesting that he keeps these contacts, and there are more and more joint publications by the academy and the industry. There is a link between both that go back and forth. He does research that don't have practical purposes, and this has happened before in the story of computing. Yuri was in Princeton, but then he started working for the British government. You've seen the movie, right? In order to decipher the Enigma codes. And this was technology or applied science. And this is another interesting phenomenon which had a big influence this century, especially with regard to processing of natural language. It was a decision made by the Association of Computational Linguistics, which is the association in the world, which decided that in the processing of natural language, there wouldn't be any paywalls. Everything was open. For IT people, this is nothing new, but in other areas, it's unthinkable. And this has accelerated development because he anticipated the phenomenon of archives, since the journals are free, are published, and are always free without paywalls. And this was a phenomenal change together with the open source developments, which are a feature of the libraries. And the last thing I learned is that it is necessary to work during the winter. As I said, the paper that started deep learning was a paper written in 1986 on algorithms, and the algorithm was even older. So this paper came from 1986. In the middle of the winter, there were people in Ghana who were working on things that were going to cause a revolution, not only in science, but also in technology, 30 years later. So let's continue working in winter and don't pay too much attention to big players and famous people.
¿Hay preguntas? ¿Alguien quiere hacer alguna pregunta? Bueno, muchas gracias.